Hi, fifth graders. Welcome back to another edition of DuckFlix. Today, we are going to explore multiplication patterns, lesson 1.5. Let's start out by reviewing the lesson scale. By the end of this lesson, I would like you to be at a 3 and be able to use a basic fact and a pattern to multiply a two-digit number. Take a minute to pause the video and review the scale. Let's move on to look at our first problem of multiplication patterns. Remember, anytime you do a word problem, you're going to want to make sure that you are using cubes. So first, when we read the problem, we need to make sure that we circle the numbers and the units, underline the question or questions, box clue words, evaluate and eliminate information that is not needed, and then go ahead and solve. So first, actual length of a queen bumblebee is about 20 millimeters. The photograph shows part of a bee under a microscope at 10 times its actual size. What would the length of the bee appear to be at a magnification of 300 times its actual size? What would the length of the bee appear to be if the microscope shows it 10 times its actual size? So let's start off by doing the first part of the question. So we'll call this question 1, and then right here we'll call this question 2. All right, so let's start on question 1. What would the length of the bee appear to be at a magnification of 300 times its actual size? And we want the magnification, which means we know it's going to be larger because we have 300 times the actual size. So 300 times the actual size of 20 millimeters. We're going to be using basic multiplication facts to solve this problem and then be able to take a look at our zeros and decide if we can find a pattern. So we're going to start with 3 times 2. 3 times 2 is equal to 6. Now we're going to focus on placing one of the zeros into the problem. So we're going to have 30 times 2 equals, we have our 3 times 2, which is 6, times the 1 0, which is equal to 10 to the first power, and 10 to the first power is equal to 10. So then 6 times 10 is equal to 60. But now we're not finished because we're going to place another 0. So now we're going to have 300 times the 2 equals 6 times 10 to the second power. Reason being is because we have 2 zeros. So that's why we have 10 to the second power. Now 10 to the second power is equal to saying 10 times 10. 10 times 10 is 100 times 6, which equals 600. And now we're going to do our last step of the problem, which is including the 0 that is placed after the 2 tens. So we will have 300 times 20 equals, and we have our 3 times 2, which is 6, times, we have 1, 2, 3 zeros, so that's 10 to the third power. Or we could say 10 times 10 times 10. Either way, I'll write it down here, 10 times 10 times 10. And that is equal to 1,000. So we have a total, this is 1,000. So we have 6 times 1,000, which is 6,000. So 6,000 would be 6,000 millimeters would be the magnification size if the actual size of the bumblebee is only 20 millimeters. Now let's solve the second part. What would the length of the bee appear to be if the microscope shows it 10 times its actual size? So for this one, we have 20 millimeters is the actual size of the bumblebee. And we want to multiply that because we want to find out 10 times the actual size. So if we multiply by 10, we're going to use the same method as we just used. We have our basic fact, 2 times 1, which is equal to 2. And then we're going to multiply it by the 2 zeros because we have 2 zeros in our problem, which is 10 to the second power. And 10 to the second power, I told you before, is equal to saying 10 times 10, which is 100. So 2 times 100 equals 200. So our answer to the second part of this problem and what the length of the bee would appear to be at the magnification under the microscope would be 200 millimeters. Another way that you can solve this problem is by saying that we have 20 times 10, and you'll notice we have 2 zeros. We have our basic fact of 2 times 1, which is 2, and then I'm going to place 2 zeros at the end of the 2 to make 200. That's kind of a little shortcut that you. Now I want you to try this problem in your notebook on your own. Go ahead and read the question and pause the video. Okay, we're back. So hopefully you were able to break this problem by using cubes. So first we're going to circle the numbers and the units, 50 millimeters. We know we have something that is 8,000 times the size of the original. And we want to use a basic fact and multiplication pattern to find the new size of the photograph. So we know that Max has this photograph and it is only 50 millimeters in size. He wants to increase the size so that the new photograph is 8,000 times the size of the original. So we have that clue word increase. We have the word times. So we know we're going to be multiplying. So let's start out by saying 50, that's the size of the original photograph, times your 8,000. And we're going to start with our basic fact. Now you need to pay careful attention because this can get a little bit tricky. We have our 5 and we're our 8. So if we do 5 times 8, we actually get 40. Notice that this fact has a 0 in the ones place. Very important that you have that 0. Don't forget that 0 because you might not add in enough zeros on the end to get the correct answer. So right now we have 40. Now let's go ahead and multiply this out. So we have 40 times, and let's see how many zeros we have. We have 1, 2, 3, 4. So if we have 4 zeros, we're going to say 40 times 10 to the 4th power. And remember, 10 to the 4th power is like saying 10 times 10 times 10 times 10. And we know that 10 times 10 is 100. And we know 10 times 10 is another 100. And we know 100 times another 100 equals 10,000. And if you're not able to do that mentally, you can say 1 times 1 is 1. And then you can add on your 1, 2, 3, 4 zeros to the end. So now we have 40 times 10,000. And that equals, we have 4 times 1, which is equal to 4. And then once again, we're going to count up our zeros. We have 1, 2, 3, 4, 5. And you're going to place your 5 zeros onto the end. 1, 2, 3, 4, 5. For a total of 400,000. That is a new size of the photograph, 400,000 millimeters. Go ahead and check your work. All right, let's go on to another practice problem. Go ahead and read the problem and pause the video. I'll be back in a second to check out our answer. Okay, and we are back. Okay, so in this scenario, Kate found an inchworm in her garden and it measured only 10. It measured only 10 centimeters in length. She placed the inchworm under a magnifying glass that made it appear 25 times its actual size. What would be the length of the inchworm? What would the length of the inchworm appear to be at a magnification of 500 times its actual size? So this is very similar to that bumblebee question. We're going to, once again, have two parts. So we have our first question that we're going to answer about what would be the length of that it would appear to be under the magnification of its actual size. And then we'll have our second part that we'll do in just a second. So just go ahead and hold that thought. So for the first question, we're going to have 500 times the original length of 10 centimeters. And once again, we're going to do this problem exactly how we did the bumblebee problem. So you should have done 5 times 1. That's your basic fact, which is 5. And then if you're comfortable, you can add in the power of 10 to the third power, because we know that we have 1, 2, 3 zeros. And 10 to the third power is like saying 10 times 10 times 10, which we know is equal to 1,000. So we have 5 times 1,000, which is 5,000 centimeters for our first part of the answer. Next, what we want to do is we want to look at the second part of the question. Now it's asking us, what would the length of the inchworm appear to be? We want to know the length if the magnifying glass shows it 25 times the actual size. So if it's 25 times the actual size, we know that we're in this problem, we're going to have 10, which is the original size, and we want to magnify it 25 times its original size of 10 centimeters. So in this part, we're going to have 25 times 1, that's our basic fact, which equals 25. And there's 1 0 in this problem. There's our 1 0. So we know that we are going to do one of two things. We can multiply it by 10 to the first, which is the same thing as saying 10, and that would give us 250. Or I can say to myself, I have my basic fact of 25. This is my basic fact, 1 times 25. And then next, what I can do is I can say I'm going to place 1 0 at the end because I have 1 0 in my problem for a total of 250 centimeters. Let's go ahead and review our final scale. I want you to take a look at the problems that you did and decide where you are so that when you come into class, Miss Addison or Miss Walker can best help you learn. Until next time, friends, this is another edition of Duck Flicks. I'm signing off. Have a great night. Goodbye.